figure something? Why do we have to do math? And the answer is, you don't have to do math. You want to do math. And we have a gentleman here who has done a lot of math and knows why it's good to do math. I don't know if you ever asked yourself that. Z, do you know why it's good to do math?
Math will make you become clever and earn more money.
Math makes you clever and earn more money. According to Z. That's the gospel according to Z. Okay, so I bet you guys didn't know that major United States corporations or international corporations like Samsung and Sony, they have mathematics and engineering departments just like colleges and universities do. Just like MIT and Harvard. If you go to the Ford Motor Company or the Chevy Company, they have a whole university with PhDs and computers and everything. And so, what I'd like to do is introduce someone who has been in charge of one of those organizations for 30 years and now is studying with the university. And so Mr. McDonald has come here to tell us how learning math and how using math can help you, as Z said, make better decisions, earn money, get stuff done. All right, here we go, Mr. McDonald.
Can everybody hear me all right?
Yeah.
No? Yeah. Can you hear me all right now? Okay, so I'll use this. All right, thank you for coming tonight, and thank you for inviting me to have a little discussion with you about math, a subject which I dearly love. Let me just give you by way of very quick background. When I was your age, at this point in high school, I loved airplanes. My goal was to fly airplanes and maybe be an aeronautical engineer. So I graduated from high school. I went off to a small liberal arts college in Minnesota. And I started taking a lot of physics, a lot of science, and a lot of mathematics. My second year in college, I read a book. And the book was entitled, What is Mathematics? Written by Richard Courant and Herbert Robbins. I love that book. That book was so clearly written about the various areas of mathematics. I threw away my love of aeronautical engineering and desire to follow that path and decided I was going to major in mathematics. So I did. I graduated from St. Mary's College in Minnesota with a degree in mathematics, having no idea what I would do with my life. What do you do with a bachelor's degree in mathematics? So I went to graduate school, and I started a graduate program in pure mathematics, and I did that up through getting a master's degree, and I had the same question. What am I going to do with my life with a degree in pure mathematics? And so I took a slightly different tack and switched to statistics, and eventually got a PhD in statistics. After that, I left graduate school and then took a position at General Motors Research Laboratories. And over a career of about 32 years there, I went from a scientist working on individual projects to heading a department, a mathematics department, in which we had about 30, mostly PhD, mathematicians, physicists, engineers, and a few other type scientists, primarily developing mathematical models about all different processes that go on in a corporation. Manufacturing processes, engineering processes, design processes, all math-based. And why math-based? Well, just briefly, in the automobile business, the old days were about when you were born. The way you brought a car into existence, you started in the design studio and literally carved clay models until the design looked what you wanted. And at that point, you digitized the clay model, developed mathematical models from those digitized data points, and then went into the engineering analysis, designing the tools that had to be done to make the shape of the metal, what you saw in the clay model. And all of that took about 5 years. That's a long time. You tie up a lot of money, a lot of people, and a lot of time with nothing to show for it. It takes you 5 years to get the car out and get it in the showroom, and you may or may not like it. You may or may not buy it. So the push in our industry was to reduce that 5-year time. And the way to do it was quit doing the physical design of the vehicle and the physical testing of it. Do it with a mathematical model. Do it in the computer based on the mathematical models that you developed for the vehicle, and do the engineering analysis in the computer. The weight analysis, the aerodynamic analysis, which affects fuel economy, the design of the tires, which affects fuel economy. Do it in the computer. You can examine alternatives, many more alternatives, and do it in a much shorter period of time. So that's the push, not only in the auto industry, but the airline industry, the same thing. I have the same discussion with my colleagues at Boeing, where instead of building and testing, they want to design math models that represent aerodynamic structures, the wing structures, the fuselage, the nose, the tail cones, all of that. Do it in the computer with mathematics and reduce the time it takes to bring a product to the marketplace. So that's a big push in industry. I was fortunate in my life. I got to participate in that, and it was very exhilarating, but you couldn't do it without mathematics. Without math, go do something else. You aren't going to participate in that challenge. All right, I could talk about that for a long time tonight, but I'm not. I think another important thing that math allows you to do is to make important decisions. We could talk about how do you analyze aerodynamic drag issues, how do you analyze wind flow over the body of an automobile, how do you design tires to minimize friction. We could talk about all of that. It all uses math, but I'm going to go up a notch. I'm going to go up to where you make really important decisions. For example, should I invest $500 million over the next 5 years to develop a new car? I don't know if you are going to like it as a consumer. There's uncertainty there. How do you make that decision? Well, you know, people hire MBAs, they hire smart people like that. I'm telling you, math can make the difference. And so what I'm going to do tonight is I'm going to go through a little example of making a decision. Now, I'm not going to use an automobile or a new product. That gets a little complicated. I'm going to give you an example that is simple. You'll be able to follow it. In fact, I'll give you a little problem halfway through it, so don't fall asleep on it. But it'll have all the right ingredients in it. And my hope is that you will see that mathematics makes a difference. Now, the little example that we'll use will be illustrative, but I hope that you'll see how it can apply to a bigger problem. It will have all the right ingredients in it. Okay? With me? Don't fall asleep now. Okay. So the title that I've used here is Making Really Good Decisions Using Mathematics. Really? What are the ingredients for making decisions? Well, let me just list them here and see if you agree with them. First, you have to have options. If you don't have any options, you don't have a decision to make. if mom and dad says, you're going to go to Winchendon School, period, end of discussion, well, that's not an option. You don't have to worry about making a decision. It's out of your hands. But maybe by the time you go to college, you might have an option. College A, B, or C. You might have an option, career A, B, or C. So to make a decision, you need options. Second, there have to be consequences to the decisions. If there's no consequences, who cares? If you've got option A, B, or C, and there's no consequences to choosing A, B, or C, who cares? Pick any one. Makes no difference. So there have to be consequences. Third, uncertainty. Most decisions that we make in industry, there's uncertainty. I mentioned if we decide to invest $500 million to bring into the market a new vehicle, there's uncertainty there. I don't know if you as a customer are going to like this vehicle. I don't know what the price of gasoline is going to be in 5 years from now. That certainly affects the success of a new product. And I don't know for sure what my competitors are going to do. I may spend all of this money and bring out a new vehicle 5 years from now, and Ford, Toyota, and VW all do the same thing. So we end up dividing up a large market that I thought we would have a major stake in to help offset my investment. So there's uncertainty. In most important decisions in industry, there is uncertainty. You have to take it into consideration. Outcomes are uncertain. Again, you don't know if you're going to get from this point to the final point. There's things that can happen along the way. And finally, there's no guarantee. There's no guarantee that if I bring this new vehicle out, that it will be a success. There's no guarantee of that. So what I'm looking at is the process that I use to make this decision. There's no process that can guarantee success, but there are processes that can guarantee that in the long run, you will be more successful. That's the mathematics. And what you look at is a process that has a higher batting average. Obviously, if you have a process that brings you success 50% of the time versus 25% of the time, I'll take the process that gets me there 50% of the time.